Bullets shouldn't be boring. Express your creativity. Make beautiful bullets. I'm gonna show you a few ideas of creating unique bullets that I'm sure will inspire you and give you the boost to take your game to the next level. We will utilize particles to make a nice fireball, then we'll play with bubbles and implement interesting spiral movement, and at the end we'll go completely insane and use particles, explosions and bouncing cats for our bullets. I'm excited, so let's get into it. Let's go though. First things first, we have to set up a couple of things before we can start making our fancy bullets. And first of all, we're going to click on project and go into project settings. We're gonna scroll all the way down to 2D physics. This is where we set up the physics layers of our game. And take note of the player hitbox and the enemy hurtbox physics layers that I set up here. And you don't have to copy all these layers, of course, this is just what I have set up, but make sure you have a layer for the player hitbox and a separate layer for the enemy hurtbox. The bullet is going to carry the player hitbox with it, and the enemy is going to be waiting with the enemy hurtbox to take the damage. Also take note of the world layer, as this is something the solid objects in the game use, and the bullets will break upon contact with them. Okay, let's make a script for the hitbox. We'll call it hitbox.gd, and it's going to inherit from area 2D. This is a very short and sweet script. All we have to do is write class name hitbox at the top and export a variable damage, which is going to be set to 0 by default. So the actual damage of the bullet is going to be defined on its hitbox. Now let's create the player hitbox scene, which is going to inherit from our hitbox. Click on it and over in the inspector expand the collision section. For the layer, choose the player hitbox, and for the mask, choose the enemy hurtbox. And real quick, I'm just gonna show you how the enemy scene is set up so it can receive the damage from the bullet. It has this area 2D which I named hurtbox, and if we expand its collision settings, you can see they are the inverse of our player hitbox. So the layer is enemy hurtbox and the mask is player hitbox. And the area has this oval collision shape. In the code you can see that I connected the hurtbox's area entered signal, which receives the area that entered it as a parameter, but because of the way that we set up our collisions, we know that this area is actually going to be the hitbox. Since we know the hitbox holds the damage property, we can reduce the health by hitbox.damage. And we can do other stuff here like display damage numbers. And now we can make the bullet script, which will inherit from character body 2D. Let's start by writing class name bullet at the top. Now let's export var initial speed and target speed, which we will both set to the initial value of 240.0. Let's also export acceleration, which we will set to 0.0. And let's export lifespan, which is going to be how long the bullet will last in seconds, so we can set that to 1.0 by default. Let's make a var speed and set that to initial speed. And let's make a var direction, which is going to be set to vector2.right. This is going to be our bullet's initial direction. In the ready function, let's set the direction to vector2.right, rotated by global rotation. This is because in Godot, a rotation of 0 degrees is actually starting on the right. Now we will make the bullet disappear after the lifespan time has expired. To do that, we'll create a new timer by writing get3.createTimer and pass in the lifespan. We will await for its timeout signal. And after that, we're just going to call Q3. Since we'll sometimes want special things to happen right before the bullet disappears, it pays to call a custom function here. Let's call it before lifespan expired, and we can implement it right down here by just calling pass. This is called a virtual function because for now it doesn't do anything, but when other scripts inherit from this one, they can override it to provide custom behavior right before the bullet disappears. And since we will sometimes want asynchronous things to happen, we will also write await right before we call it up in the ready function. And now all that's left to do is make the bullet move. And we will do that in the physics process function. To calculate the speed, we will use lerp or linear interpolation to change the speed towards target speed, by acceleration times delta. And then we get velocity by multiplying direction times speed times delta. To move the bullet, we'll call move and collide and pass in the velocity. Move and collide returns information about the collision, so let's save that into var collision. Now we can just check if collision has happened with if collision, and if it has, we delete the bullet by calling queue_free. Now the bullet can detect collision with bodies, but what about colliding with the enemy hurtbox area? Well, unfortunately, a character body can't detect areas, so it would pass right through. But you know what can detect areas? The player hitbox we created earlier. We're going to add it onto the bullet and let it tell us when it encounters the enemy hurtbox so we can destroy the bullet. At the top we're going to write onReadyVar player hitbox and try to get it from the scene tree. Now of course, since this is just a script that we will attach to any bullet scene from now on, we might not have this player hitbox in place. So in the ready function we're going to first check if player hitbox even exists. And if it does, we're going to connect its area entered signal and specify the onHitbox area entered function as the callback. Now Godot is unhappy because onHitbox area entered function does not exist, but we can create it right now. It's just going to have pass in it for now, but if we ever want the bullet to destroy itself when it hits the enemy, we can override this function and just call queue_free inside it. Also, don't forget to add the area parameter, as the area entered signal requires this parameter in its callback function. And this is all we need to make a functional bullet, but we can also use this script as a basis to create our fancy bullets. So let's start with making the fire bullet. Notice how we have the fire particle trail, the bullet shrinks before it disappears, and it pierces through enemies and solid objects. Let's make a new scene, call it fire bullet, and make the root type our bullet node. We're going to add a sprite node, and take note how the sprite I'm using is turned to the right. This is because of the rotation that we were talking about earlier in the bullet script. The default rotation is to the right, so your sprite should also be pointing to the right. Let's add a collision shape and make the shape a circle which is about the size of the sprite. Let's instantiate our player hitbox scene and also add a collision shape inside it. This one is going to be a bit bigger because it's good to be more generous with the hitboxes. Click on the player hitbox and you can set up the damage in the inspector. Now click on the root node and we can set up the parameters of our bullet. We're going to keep initial speed, target speed and acceleration the default, but we'll change lifespan to 0.5 seconds. Expand collision and we can remove it from all layers and all masks. This will effectively make it pass through solid objects. Now let's make the fire trail by adding the CPU particles to the node. And we will transform these falling white squares into something much more impressive. Change the amount to 100. Under time, pre-process to 0.1 seconds. Under drawing, turn on local coordinates. Under emission shape, change the shape to a sphere. Under direction, change the direction x to -1 and spread to 0. Under gravity, set the gravity y to 0. Under initial velocity, set both the minimum and the maximum velocity to 50. Under scale, make a new curve so we can change the scale over time. We'll set the maximum value to 4 and make it start at 4 and taper down to 0 by the end. And finally, under color ramp, make a new gradient and make it go from a red to a yellow. If we look at how we want the bullet to shrink, you can notice how both the sprite and the particles shrink together. To achieve this, we'll need to put them under the same parent, just a regular Node2D, and we can call it sprite group. Just make sure that the CPU particles node is underneath the sprite. Now we can change the sprite group's scale, and they both shrink together. Wonderful. Now we can make the fire bullet script by right-clicking on it and choosing Extend Script. We'll delete this whole template and just leave extends bullet. First we'll get to sprite group with onReadyVar sprite group and get it from the scene tree. Then we're going to make the bullet scale down over time in the ready function. But before we do anything else in the ready function, we first have to call super.ready. This will execute the parent bullet script's ready function, which otherwise wouldn't be called. So anytime you're making a new bullet and you're overriding the ready function, be sure to first call super.ready. Now we can make a new tween by calling get3.createTween. We're gonna use this tween to scale down the bullet, and we're going to do that by writing tween.tweenProperty. We have to specify which node we're going to be changing, and that is going to be sprite group, which property we're changing, and that is scale, the final value, which is going to be vector2.0, and the duration of the animation, which is going to be lifespan over 4, so a quarter of the bullet's lifespan. We don't want the bullet to scale down immediately though, so we'll call .setDelay and set up the shrinkage to happen after 3/4 of the bullet's lifespan, so 3 times lifespan over 4. And that's it, we now have an awesome fire bullet. So let's continue on to making the spiral bubble bullet. And as you can see, because of the spiral movement, when we have just one bullet, it doesn't really look right, so I will be demoing it with multiple bullets shooting in 360 degrees. Notice how besides spiraling out, the bullet also slows down by the end of its lifespan. Let's make a new scene and make the root node the bullet. Let's add a sprite and a circular collision shape, which is going to hug tightly to the sprite. Let's instantiate our player hitbox scene and add another collision shape 2D, which is going to be a circle again, and it's a little bit bigger than the sprite because, again, we're generous with our hitboxes. Click on the player hitbox and you can input any damage you like. I'm gonna set it at 2. Click on the root node and let's set target speed to 0 and acceleration to 2. Now our bullet will actually slow down instead of keep the same speed over time. Expand collision and remove it from all layers, but we'll keep the world layer for the mask so it collides with solid objects. We want the bullet to pop into existence and pop out once the lifetime is done, and we'll do that with an animation player. So add the animation player node. Let's make a new animation and call it spawn. Set its duration to 0.2 seconds. To be more precise with our keyframes, we'll change the snap down here from 0.1 to 0.02. And now we can select our sprite node, and in the inspector under transform, next to the scale parameter we can press this key icon to insert a keyframe into the animation. Click on the created keyframe and we can set its values in the inspector. We're gonna put both X and Y to 0 to start with. Then we're going to move the playhead up to the 0.08 seconds point. Here I'm going to duplicate the first keyframe and change the values to 1.25 for both X and Y. I'm going to move the playhead all the way to the end of the animation, so at 0.2 seconds, and duplicate the keyframe once again. This time I'm going to set both the X and Y value to 1. And this gives us quite a satisfying spawn animation. Since we want this to play right when the bullet spawns, I'm going to check the autoplay on load option over here. Let's create a script for the bullet, again by right clicking on the root node and pressing extend script. Make a variable called rotation speed and let's set it to 4.0 by default. Now we're going to implement the rotation movement and we're going to do that in the physics process. And just like with the ready function before, when we override the physics process, we first have to call super.physicsProcess and pass in the delta. This will execute the bullet script's physics process before we do anything else. And now we can adjust direction by setting it to direction.rotated and passing in rotation speed times delta. That's literally all we need to make the bullet spiral. Now we can play the spawn animation in reverse when the bullet is getting deleted. So we're going to get the animation player from the scene tree. And now we get to use the virtual before lifespan expired function we prepared earlier. If you remember, this is the function that gets called right before the bullet's lifespan expires and it gets deleted. In here, all we have to do is call animation player.play backwards and pass in the animation name, which is spawn. And then we have to await animation player's animation finished signal to make sure the animation is finished before the bullet gets destroyed. And I also want to destroy this bullet once it touches the enemy, so we'll use the other virtual function we prepared, which is onHitboxAreaEntered with the area parameter. All we have to do in here is just call queue_free. And now this bullet can't pass through enemies. There is just one more thing missing to tie this all together, and that is the splash particles that get emitted when the bullet is destroyed. We're gonna create these particles in a separate scene. So make a new scene, call it bubble bullet splash, and make the root type CPU particles 2D. Set the amount to 2. Under time, set explosiveness to 0.75. Under drawing, for the texture, set the same sprite we used for the bubble bullet. Under emission shape, set the shape to sphere and the sphere radius to 2 pixels. Under direction, change the spread to 180 degrees. Under gravity, set everything to 0. Under initial velocity, set both the minimum and maximum velocity to 25. Under scale, create a new curve so we can change the scale over time. Set the minimum value to 0.25 and the maximum value to 0.5. That's how we want the splash particles to look, but we don't want them to repeat over time, we just want them to happen once, so we'll scroll back up to time and turn on one shot. Now the particles will emit once and then stop emitting, but they will still be loaded in the scene, which is not what we want. So let's create a new script that will delete them once they stop emitting. All we have to do is in the ready function connect the finished signal to a lambda function that is going to call queue_free. Back in the bullet scene, we're going to connect the bullet's 3 exiting signal so we can spawn the particles when it exits the scene. Click on the root node and on the right change the tab to node. Find the 3 exiting signal, double click it and press connect. This will create the onThreeExiting function, which will get called before the scene gets deleted. And here we're going to instantiate the particles, so let's go to the top of the script to preload them first. OnReady var splash particles scene equals preload and pass in the path to the scene. In the onThreeExiting function, we're going to instantiate the particles by writing var splash particles equals splash particles scene dot instantiate. We're gonna set the splash particles rotation to the rotation of the bullet. And similarly, we're going to set splash particles global position to the bullet's global position. And we'll set the splash particles emitting property to true. Now we just have to add the particles into the scene tree, so we'll call getTree.root.callDeferred in quotation marks add child, comma splash particles. And that's our bubble bullet complete. And now let's make our final and the most ridiculous bullet, the bouncing cat bullet. This one doesn't hurt the enemy directly, but it spawns an explosion that is a kind of area of effect attack. Notice how it doesn't collide with the enemy right when it spawns, but it kinda bounces over it at the start of its lifetime. Let's make a new scene, call it cat bullet and make the root node the bullet. Let's add a sprite, and I will actually be using a random sprite, which is a custom node I created in one of my previous Godot tutorials, and it just chooses one of the sprites in the sprite sheet at random. You can use just a regular sprite 2D and it's gonna work just as well. Since the cat is bouncing, we're also going to need another sprite for the shadow, so we can determine the cat's position in the world and also sell the effect of the bounce. Let's add a collision shape, which is going to be a circle again, and it's going to be just about the size of the cat. Let's instantiate our player hitbox and copy this collision shape into it. We're gonna set the damage on the hitbox to 0 because we don't actually want it to do any damage. We'll just use it to detect when the cat hits the enemy, so we can spawn in the explosion. Let's add the animation player and create a new animation called bounce. Click on the cat sprite and under transform, click on the key next to position. Click create, and this adds a new keyframe for the position of the sprite. We also need to animate the position of the collision shape 2D, so click on it, and under transform, click on the key next to position and add that keyframe as well. Put the playhead at 0.5 seconds and duplicate both of these keyframes. Here we'll change both of their position wise to -16 pixels. Then move the playhead all the way to the end and duplicate the first keyframes. Now if we play the animation, we can see both the sprite and the collision shape move up and down, but it looks like we forgot something, and that's the player hitbox. So let's just repeat all the same steps to animate the player hitbox's position. Let's also enable looping by clicking on this button. And now we have the finished bounce animation. Let's finish up with the scene by setting up the bullet parameters. We're going to set initial speed to 600, the target speed to 120, and acceleration to 1. Now let's make a new script by right-clicking on the root node and clicking Extend Script. First we'll get the animation player from the scene tree with onReady. Then we'll override the ready function, where again first we have to call super.ready, and then we'll make so the cat bullet doesn't actually rotate to face its direction like other bullets, cause that wouldn't look good with this sprite. So we'll set global rotation equals 0. Then we'll play the bounce animation by calling animPlayer.playBounce. We'll tweak the animation player's speed scale so it always results in 3 bounces over the lifespan of the bullet. So we'll call animPlayer.speedScale equals 3 over lifespan. Now we can implement the bullet not being able to hit the enemy or the solid objects at the start of its lifespan. This is to sell the effect that it's jumping over these objects at the start. So we'll first get the collision shape and the hitbox collision shape from the scene tree right at the top of the script. Then back in the ready function we will disable both of them. We want to re-enable them after a bit of time has passed, so let's create a new timer by calling getTree.createTimer and pass in lifespan over 4, and we'll await for its timeout signal. Now after the timer has finished, we can just re-enable them by setting their disabled property to false. Let's implement destroying the bullet when it hits the enemy, like with the bubble bullet before, by overriding the onHitboxAreaEntered function. And just like before, we're gonna call queueFree. Now we got this cat bullet going, but it's pretty useless, it doesn't even explode when it hits the enemy. So let's make the explosion. We create a new scene, call it explosion, and just leave the root type to be 2D scene. We'll add an animated sprite, and I'm just using a simple sprite sheet of 4 frames to create the explosion animation. When I play it, it's a bit slow, so we'll increase the speed to 10 FPS. I'll press this button to stop the animation from looping, and this one to toggle autoplay. Now let's also instantiate the player hitbox onto the explosion, and add a collision shape 2D onto the hitbox. We'll create a circle shape again, and make it quite a bit bigger than the explosion sprite. Click on player hitbox, and now we can configure the explosion's damage. And for this, I'm going to put in 20. Now we just want the explosion to disappear from the scene tree once the animation ends, and to do this, we'll add a new script onto the root node. We can delete all this auto-generated code, because what we actually want is to select the animated sprite 2D, and on the right side next to the inspector, switch over to the node tab. Find the animation finished signal, double click it, and press connect. This will create the callback method for when the animated sprite finishes its animation, in which we'll call queueFree. Now back in the cat bullet scene, we want to instantiate this explosion when the bullet is destroyed, so we'll click on the root node and find the tree exiting signal. Double click it and press connect. This creates the onTreeExiting callback function in the cat bullet script, but first we need to preload the explosion scene, so we'll go back to the top of the script, and with the onReady we're going to preload the explosion scene. Now back in the onTreeExiting function, we can create a new explosion scene instance by writing var explosion equals explosion scene.instantiate. Then we'll set the explosion's global position to be the same as the global position of the bullet. And finally we'll add the explosion into the scene tree by writing get_tree.root.callDeferred in quotation marks add child, explosion. And now the last thing we have to add is the dust particles. And I'm going to quickly show you what the particles scene looks like. We only have one node, which is the CPU particles 2D node, and these are the settings. I put the amount to 4, and under time I put the explosiveness all the way up to 1. Then under drawing, for the texture, I used the simplest dust particle sprite you could think of. Under direction, I put the direction x to 0 and direction y to -1. And I also put the spread to 90 degrees. Under gravity, I set everything to 0. And under initial velocity, I set the velocity minimum to 4 and velocity maximum to 8. Under linear acceleration, for the acceleration curve, I made a Bezier curve that goes from 1 to 4. Under scale, I set the scale amount minimum to 0.75 and the scale amount maximum to 1.25. And finally, under color, I made a color ramp, which is a gradient that goes from a full white to a transparent white. Also, if we scroll down to ordering, I set the z-index to -1, so it appears behind other sprites. Now we should scroll up to the top of the CPU particle settings and enable one shot. And if I open up the script I have attached here, you can see that it's exactly the same as the script we had for the bubble particles. We just connect the onFinished signal and inside it we queue-free the particles. Now back in the cat bullet script, we preload the particles right at the top. We'll make a function called createDustParticles, which we will call from the animation to create the particles. So we make a new dust particles instance by writing var dustParticles equals dustParticlesScene.instantiate. We set its global position to the global position of the bullet. And we set its emitting property to true. And we add it into the scene tree the same way as before by writing getTree.root.callDeferred in quotation marks add child, dust particles. And now in our bounce animation we want to spawn these particles right at the last frame. So pull the playhead all the way to the right, click on add track and choose call method track. Now this pop-up window is asking us which script's method we're going to call, so just choose the cat bullet and press OK. Now you can see the new track has appeared in the animation editor, and you can right click on it and press insert key. Now Godot will ask you which method from the chosen node you want to call, and you can just search for dust and you can see the createDustParticles function. Double click it and this adds a new keyframe into the animation. So now whenever the animation reaches this point, this function will get called and it will spawn the dust particles. I'd love to see some awesome bullet designs you can come up with, and you can share them with me and the community in the Discord channel. I'll leave the link in the pinned comment. I hope to see you there. Other than that, thank you for watching.